again, thanks everyone for joining us today. We're super excited to have Lance talk to us about the future of RAG in the world of long context LLMs. See some activity in the chat. Hi, Fabian. Hi, Francesco. Hi, Thomas. Yeah, this is great. Yeah, if you want to just introduce yourself, where you're from in the chat, that'll be great just to get a sense of where everyone is. Hi, Daniel. That's great. Okay, I'm going to do a short introduction and welcome and just do a quick plug for Timescale, and then I'll hand it over to Lance, who's going to handle the bulk of the session. Great to see people in the chat. We have folks from Belgium, Brazil, Vancouver. This is great. So we're really happy to be hosting Lance from LangChain in this webinar, telling you a little bit about Timescale. We're basically building the best vector database on Postgres. So if you want to build AI applications with Postgres as your vector database, please go and give Timescale a look at. We have integrations with LangChain. This is a snippet of some of the code that you'd use to use Timescale and LangChain together. We launched that last year. And then final thing before I hand over to Lance, there's a special offer for folks in this webinar. If you want to sign up to use Timescale as your vector database, we're giving folks a 90-day free trial. You just go to this URL, tsdb.co/webinar-signup. I'll also put it in the chat for folks to have. But if you want to take it for a test drive and evaluate it as your vector database, you're more than welcome to do that. Okay.
As I mentioned in the chat, I'm here in San Francisco, California. It's morning. It's a cloudy day, and I'd probably rather be in many of the places that you guys are. So the talk today is about RAG, and the uncontroversial title is RAG Really Dead? So the first point is that we all know context windows are expanding. So on the x-axis is showing the number of tokens LLMs are trained on. So it goes from like small models like Phi-2 trained on 1.5 trillion tokens on up to some arbitrarily large number we don't quite know for closed source models like GPT-4 and Claude. But more interestingly, on the y-axis, we have the context window of various LLMs. So even about a year ago, context windows were somewhere in the range of 4K to 8K tokens. We saw Claude 2 release earlier this year with 200K. And now we see models with up to 1 million tokens of context length with Gemini 1.5 and Claude 3. We've also seen a lot of open source models expand their context length with things like rope and self-extend. So I think betting on context windows of LLMs getting larger is like a good bet to make, and it seems to be increasingly happening. So this has brought a lot of questions up. Is RAG actually dead? If you can stuff 1 million tokens into an LLM, that is thousands of pages of text. That's hundreds of documents. So do you need an index to actually store those documents? Why can't you just stuff them all into the context of an LLM without any sort of retrieval? So just as like a level set, what is RAG? You can think about RAG really as reasoning and retrieval on chunks of information, starting with something like an index. So you have your documents, you've indexed them in a way that they're easily retrievable based on something like semantic similarity, for example, to a question. So you can retrieve relevant docs to a question, you pass them to an LLM to ground a response based on the retrieved docs. So that's the flow. Now, a first question to ask is, if long context LLMs can replace RAG, they should also be able to do this. They should be able to retrieve specific facts from the context you give them and reason about them and return an answer based on them. So I actually tested this with 𝗥𝗲𝗃𝗃, who did some recent analysis called Needle in a Haystack. I extended this to be comparable to RAG, allowing you to place multiple needles into the context of an LLM. So here's the setup. The question you can ask an LLM in this case is, what are the secret ingredients needed to build the perfect pizza? And what I do is I inject needles. Each needle is one secret ingredient into the context in some specified location. You can be at the beginning, middle, and end, for example. And what I do then is I ask the LLM, given this context, what are the secret ingredients? And I place them in a background of Paul Graham essays. So it's like a background of unrelated content. We call that the haystack. And then the 3 needles are the 3 pizza ingredients. And so we can test, can it find those needles? And if it can't, which ones does it fail on? So that's the setup. And I did this with 𝗥𝗲𝗃𝗃. We looked at GPT-4 And what we found are some interesting results. So on the left, you can see on the x-axis are the number of different needles. So you can place 1 fact, 3 facts, or 10 facts. And on the y are the percent that you get correct. So the percent of needles you actually are able to retrieve from the context. Now this is testing 120,000 tokens, so it's a long context. And we're testing just retrieval, or retrieval and reasoning in this case is just give me the first letter of each ingredient. So it's like a little bit more challenging than just retrieval. So you can see is as the number of needles goes up, performance goes down. Kind of what you would expect, right? Retrieving 10 needles is harder than 1 needle. And what we also see is that reasoning is a little bit harder than retrieval. Makes sense. But what's even more interesting is we looked at basically on the right here, on the kind of y-axis of this heat map are all the different needles. Like the top needle is the start of the doc, the bottom needle 10 is the end of the doc, and the X is showing you different context lengths. Red is you didn't get it, green is you got it. So here's the point. If you look at 1,000 tokens, so short context, you place 10 needles in the context, it can get them all, no problem. But as you make that context bigger, 2,500 token, 25,000 tokens up to 120,000, you miss needles at the start of the document with GPT-4. So you can think about it like this. You read a book, it's a long book. I ask you questions about the book from the beginning. You forgot the beginning. You can remember the end better than the beginning. This seems to also occur with long context LLMs, at least with GPT-4. So I put this out on Twitter. I asked people like what might be going on, and I found this really cool paper. It's probably recency bias in the LLM. So if you think about the training objective, predicting the next token is often mostly governed by nearby tokens. So the most informative tokens for next token prediction are probably the ones that are recent. So it learns a bias to attend to recent tokens in answer generation, which is not a great prior in like retrieval tasks like we're talking about here. So it's an interesting point, and it does give you some pause about, can I just use a long context LLM for something like retrieval in this case? It depends, right? If you look at the data, depends on your context length, depends on where you place the facts. So I think this gives some pause to this idea that you can just do away with RAG altogether and just rely on long context. Now, this will get better for sure. And this is maybe a funny quote from Frank Zappa, musician, talking about jazz. He said, jazz isn't dead, it just smells funny. So it's saying jazz is not gone, it just is different. And I think RAG is like the same idea. RAG isn't dead, but it's definitely going to change. And if you think about RAG today, it's really focused on precise retrieval of just relevant chunks. So typically the flow is something like you take documents, you split them into small chunks, you embed those chunks, you ask a question, you embed the question, you do similarity search, you get relevant chunks out, you often filter them with re-ranking or compress them, and you just send in the right amount or like the most relevant information to the LLM to answer the question. That's the paradigm today. And I think it's asking, in the world of long context, what's the right optimum in the middle here? I think on the right, we showed stuffing all your documents may or may not work well, depending on the context, the LLM biases, where you put where the facts are present. But even more importantly, it has higher latency, it has higher token usage. You can't independently audit retrieval. And this brings up a lot of like security authentication issues, like in the corporate context, like you need a system that can gate information for different users. And if you just have a long context LLM with everything stuffed in, it's not obvious to gate retrieved information based upon security settings or user or something like that. So anyway, I think this notion of just stuffing everything is naive. It's probably not optimal. But on the other hand, I also think today's paradigm of very exacting retrieval You can risk over engineering, high complexity. You can suffer from lower recall. There's a lot of weird parameters in RAG today, like the chunk size, K, that are like very brittle. So I think what can we find in the middle here that is like a better approach? I put this out on Twitter, and actually I think a really simple but reasonable notion is like using documents as your minimum unit. So not document chunks, which we do today, but just like indexing and retrieval over documents is probably reasonable. Most documents will fit within the context window of LLMs, especially as we go out to very large context windows. And it gets around the notion of having to retrieve chunks. So this is one idea. And we've been doing some work recently on the RAG stack and the components you would need in this world. So you think about the first part of RAG, which is usually like what we call query analysis, which is you have a question, you want to route it to the right document in this case, or the right database in the case of like a SQLDB or GraphDB. And so I think in the long context world, this kind of doesn't change. Like you still want ways to potentially rewrite questions or decompose them. You still want ways to route questions to the right data source, your vector store, your SQLDB, your GraphDB. You still want ways to convert text into whatever DSL, like SQL, Cypher for graphs, metadata filters for vector stores. So I think this all kind of stays in place. But I do think there's going to be changes at the indexing layer. And one idea that we've used quite a bit, which is really nice, is this idea of representation indexing. So there's a paper on it. I'll share these slides. But the main idea is you can take a document, use an LLM to just summarize it. And you can write the summary prompt any way you want. And then you embed that summary and you use the summary for retrieval. So this takes away a lot of the documents can be really long, they can be redundant. If you embed the whole document, your embedding quality may drop for retrieval. But if you embed like a nice compact summary of the document, it's like a nice way, or like we would call like kind of a representation of that document that's well suited for retrieval. And what we do is we still use the full document in the generation step. And so this multi-representation indexing flow simply connects the full document with the summary representation. And at retrieval time, you retrieve based on the question's similarity to the summary, but you return the full document. So it's a nice flow. You get the best of both worlds. You get clean retrieval, but you still pass full documents back to the LLM for reasoning, because you want the full context. The LLM can handle the full document, and you want as much detail as possible in the generation phase. So this is a really nice trick that I like. Another nice trick is based on a paper that came out recently called RAPTOR. So the problem statement here is sometimes you have questions that require multiple documents to answer, that like span like a higher level, like abstraction over a few documents. Like say you have a question, it references like ideas in 3 or 4 documents, right? How do you do that? You have to retrieve each one and pass each one. RAPTOR presents like a nice alternative way, where what you do is you take the documents, you embed them, embed each one, you cluster those embeddings, and then you basically summarize the documents in each cluster. So you're basically summarizing similar documents to build like a compact, higher level representation or abstraction. And then you keep doing that until there's no clusters left. And you build what we call this summary tree. And what they showed is you just basically embed the raw documents along with these higher level summaries. And when you embed them all together, you basically do retrieval on that mixed pool. So you have a question that references ideas in like a few different documents. You can retrieve like a summary that captures that. It's a nice trick. I have a notebook here and a video where I've shown that this works really well for full documents. And it's kind of a nice approach for this problem of what if I need to handle questions that are higher level that require ideas from many documents? This kind of like summary tree idea is like a nice trick. So I think it's another thing to consider when you're operating in kind of this document domain. Long context embeddings will get better and better. I think it's really good to think about. We have long context embeddings up to 32,000 tokens today. And I would encourage experimenting with these, because this plays really well with RAPTOR, because you can just embed full documents without any chunking with long context embeddings, assuming your document's less than like 32,000 tokens, which is not always the case. But the point is long context embeddings are getting better and they're getting longer. So I think more and more documents will fall within this regime of long context embeddings. Now, the last thing is a trick that I've been using quite a bit lately, which I really recommend. And what it is simply thinking about RAG as like a one-shot process where you do retrieval and then generation is limited. Like you can do retrieval, you can look at the documents, reflect on them. If you don't like them, if they're not relevant to the question, you can retry retrieval. You can rewrite your question and retry. Likewise, if the documents have, or if the answer has hallucinations, you can retry the generation. You can modify the prompt. Likewise, if the generation doesn't answer the question, you can retry. And so there's a lot of cool papers on this. I call this kind of like active RAG or self-reflective RAG. But the idea is you're building kind of a feedback loop in your RAG stack to actually do different kinds of grading on your retrieval and or your generation to improve quality. And so I think it's really extending the idea of reasoning after the retrieval phase. I've actually implemented this using LangGraph, which is, you can think of this as like an agentic flow. LangGraph is really nice because you can basically specify this as a graph, and it's a bit more reliable than using like an open-ended agent to orchestrate this process. I have a notebook and video on this, which are linked below, and I'll share all the slides. But this is, again, another really nice trick to move from thinking about RAG as a single shot process to more of a reasoning loop where you can do like reasoning, grading, and around your retrieval. So that's another thing. And I'm going to leave a lot of time for questions. This is I think the end here. So to summarize, I think moving towards, one, I think RAG is not dead, but I do think it changes. I think RAG at the document level is pretty reasonable to think about in a long context regime. I think the kind of reasoning pre-retrieval, like query construction, query analysis, routing, are all still relevant in this world. You still want to route queries to the right document. I think indexing can change a lot. You can use methods that optimize for documents, like this multi-representation indexing idea, where you basically summarize documents, retrieve based on summaries, but return full documents, or RAPTOR, where you cluster documents, summarize clusters, and build trees to easily consolidate information across documents. And then I think techniques like self-RAG or CRAG, which I didn't quite talk about, but I do have linked, are really interesting for that post-retrieval reasoning phase, which will still be relevant in the world of long context. You'll always want to grade your answers. You'll want to grade, in that case, your retrievals. Indeed, if you're doing full document retrieval, you still would like to grade that to confirm that's relevant. So I think this is an overall picture. I think we have a lot of questions.
So there's quite a few questions in the chat. So thanks everyone for submitting those questions. We'll keep your slides up, Lance, just in case you need to refer to it. Maybe what I can do is I can read out the question and then I'll hand it over to you to answer.
Yeah.
Does that work? Okay.
Yeah, that'd be great. That'd be great.
We're gonna start with a question from Daniel Forberg. So Daniel asks, how about the costs of using the long context window input and the number of tokens? So I think more broadly, it's just about the costs of using these long context models and what your thoughts are on them.
Yeah. So I'll tell you something funny. To do this analysis, this needle in the haystack analysis, I burned a lot of tokens. I was actually pretty worried that my boss, Harrison, was like going to be mad at me, because once you get up to that 100,000 token regime for GPT-4, it's around $1 per generation. So that really adds up. I did, you can see, I don't show all the replicates, but I probably burned hundreds of dollars. So I totally agree that cost is a real concern, especially in the production setting. I think that's a very valid point, which is why in this framing here, I definitely think that even though costs will go down, there will still always be relative competition between different offerings based on cost. And I don't think it's efficient to arbitrarily stuff all of your documents, for example, into context for generation, I think that will never be optimal. So it's really finding this balance between something that's like maybe too stringent, too over-engineered, like just trying to find the exact right chunk has a lot of issues, and stuffing everything has a lot of issues just in terms of inefficiency, cost, token usage. So that's why I think about this notion maybe of documents being a reasonable abstraction or like primitive unit for retrieval, because documents are self-contained, they're easy to work with, and it's still limiting the context in most cases to the scope of one or two documents, which is certainly not on the scale of full stuffing your whole corpus. So anyway, that's my take on cost. It's very important to watch. And actually, Q3 is more expensive than GPT-4, I believe, at least Q3 Opus, which is their best model. So yes, cost is a real issue.
I think you're very much right. I think one thing that, if I could just add an opinion here, is that if you look at the trends of cost per token for these models, even just in the past year or so, since GPT-4 has been released, and you can go back 6 months before that as well, these costs are generally moving down over time. And so what I often hear people talk about is, if you're building a system that has production users today, then obviously cost is a very real concern, and you should do what's best for you there. But if you're building for the future, you can build for what the costs are going to be in 6 to 12 months. And there's a good bet that those costs are going to be lower than they are today if you look at the trend. So that's also something to keep in mind, that these costs are decreasing over time, making it easier to afford to use these models.
Absolutely.
Awesome.
That's right.
Okay, next question. One question from Reed talks about, it's interesting that all context windows are not created equal. Someone told me yesterday that GPT-4 misses needles in the middle of the data, but Claude 3 is able to find them. Have you experimented with that? Just curious.
Yeah, okay, that's a great point. So there's a paper from Stanford, Percy Lang's group, that's called Lost in the Middle, that argues or observes that GPT, in that case, here's the catch, it was GPT 3.5, and it was looking at 4K context as well, so much smaller context, GPT 3.5, so much earlier model. In that case, it did find retrieval problems in the middle. Greg, who did a lot of these studies on GPT-4, and I both have seen this result of more lost in the beginning for GPT-4 128K. So I think the patterns of failure differ per model, and they should be studied per model. I did the same thing with Claude 3. I need to finish the analysis. I did observe a different pattern for Claude 3 than this. I actually saw, though, retrieval failure is more in the middle, but I need to finish the analysis. Basically, I think model providers should do a better job providing like rigorous needle and haystack analyses that are realistic. What they provide today shows like it's perfect across the board. I think they're probably not hard enough. And there's been some interesting results on this. Like I showed the multi-needle thing is much harder than single needle. That's one. They've only done single needle. And then two, the question for that single needle thing is often like pretty like easy. It's like a fact about San Francisco that's like way out of context. Anyway, the point is, it'd be encouraged to run these yourself. Everything's open source. The video is down below. It links to all the code. It's not that expensive to do like just a few trials for yourself to test. But I think the patterns differ for every model, and model providers need to do a better job, basically more rigorously pressure testing these things. Because when they give you a result that's just all green across the context from 0 to 1 million tokens, I don't believe that at all.
Got it. That's super interesting. Question from Jatin. Jatin asks, for self-RAG, which is a technique that you mentioned in the talk, how do you choose and define the eval metrics to know when to initiate the feedback loop?
Yeah, exactly. This is a great point. So I have a notebook attached. I'll share all these slides, by the way. I have a notebook attached to the below video where I talk about it. So I use binary scoring, and I just have an eval prompt that's pretty trivial. Here's my question. Here's the retrieved document. Is the retrieved document relevant to the question? I use GPT-4, and I return a binary score of yes, no, because that's easier for downstream processing in my graph. So that's how I do it. I think it's pretty nice and pretty easy to structure it that way. You can obviously have like a categorical scale, 1 to 5. My experience is LLMs can have more of a difficulty with that qualitative grading. Binary score, use a high capacity model, simple grading prompt is pretty effective. I use function calling to restrict the output to yes, no preamble, so that can be easily logically processed. And all the code shared, so I'll make sure that these slides are. In fact, I'll put these slides in the chat right now, just so you have them, and you can browse through.
Go for it. Let's do it live.
Yeah. Let me see. Where can I type my answer? Oh, I see.
I just put it in.
Anyway, you can go to the next question while we're at it.
Awesome. Awesome. Okay, so the next question is going to be from, let's keep on the topic of self-RAG. So Jonathan Yap asks, for a real-time search use case, doesn't the self-RAG example have a lot more latency if it's going back to the LLM for eval steps? Yeah, maybe we can chat about that.
Yeah. Okay, this is a good one. This came up as well in some other talks I've given on this. So I totally agree. I think it's a trade-off between like answer quality and latency. That's always the case. So I think there's a few things you can do to mitigate this. One, you can use a fast LLM as the grader. I think it's good enough, most likely. For example, testing Grok, which is extremely fast with various open source LLMs, could be really interesting here. GPT-3.5 Turbo, which is obviously quite fast, is probably good enough because these grading challenges are not really that hard. Assessing a question relative to a document or like an answer relative to a document are not crazy if you want to just catch hallucinations or like egregiously wrong retrievals. That's not too hard to do. You can use a really fast LLM and you can restrict it to one iteration or 2 iterations. So like try once. If it still gets it wrong after one, just give it the answer. So you can mitigate that concern quite a bit with a fast LLM for grading and for like limited iterations, but it's absolutely a good point. There's always a trade-off between like answer quality and latency.
The next one is going to be from Cameron, who asks, do you think long context embeddings lose their semantic usefulness? Could a single embedding really represent a 32K token document?
Yeah, that's a good question. I honestly haven't worked that much with 32K context embeddings. So I would honestly need to convince myself that they really perform well. But if you look at all the trends in model development, like high capacity over long context is just getting better and better. So I have confidence that they will simply get better. I think it is worth looking at the work on Monarch Mixer from Stanford. Their embedding model, which is 32,000 tokens, is on, I'll share the link in the chat. It's on Together AI. I have not played with it personally, but they use a different architecture. They don't use a transformer. They use this Monarch Mixer, which apparently has better attention over long context. And I think it's very interesting. I would encourage you to play with it. I would be skeptical, but optimistic with your testing and have a look. My sense is any bet you make that like it won't get better is usually wrong. They're just going to get better. But to be honest, I have not played very much with the 32,000 context embedding yet. I've done a lot with Ada 2, which is 8K. That obviously I have pretty high confidence in. So I think it's worth having a look.
So Ikra asks, what's the most reliable methods to test a RAG pipeline? Using the LangChain criteria evaluator, is there any reliable measures to test relevancy and correctness? This is more about testing and eval.
Yeah, that's a good one. Within LangChain is an open source library. We also have a platform called Langsmith, which supports evaluations. And we have a lot of ways to evaluate RAG. One thing, typically the workflow works like this. You have a set of question answer pairs that you specify and put inside a data set. You then build your RAG pipeline. You run your RAG pipeline on all the questions. You run and compute answers from your RAG pipeline. You compare those to the ground truth answers, and you can use a bunch of different evaluators to do that. We have a few out of the box. They typically just look at kind of pairwise similarity between answers based on semantics. And this is the standard kind of workflow for evaluation of RAG, which is pretty sane. I've used it quite a bit, and I found it does work well. Some other tricks I like, though, I will share something. So I recently did a thing on code generation. This is kind of like RAG plus code gen. And in that case, code assistant, let me find this LangGraph code assistant. Yeah, LangGraph for code generation. Have a look at this. So here, I actually defined some custom evaluators to test like in your answer code imports and code execution. So all I'm trying to say is if you just want to test like you relative to ground truth answer, semantic similarity between the ground truth answer and your RAG generated answer, you can use off-the-shelf evaluators in Langsmith, like the COT evaluator or the QA evaluator. The COT, QA, or QA evaluators work really well. If you want custom evaluators, you can also do that. You can look at the report I just did that shows custom evaluation for code checks, so for code imports or code execution, which is another nice overlay depending on your RAG application. I'll also share Langsmith evaluators. Yeah, and we can go to the next question. I'll share this while we're going.
Fantastic. Okay, so one of the most upvoted questions we have left is around, it's from Novice.
Yeah.
He says, or they say, we usually only use RAG for domain-specific question answering. What other common application scenarios are there?
Okay, so I guess when you say, so RAG generally is a paradigm of, retrieval plus, answer generation. There's a huge number of different domains in which you can apply that. We use RAG for our documentation. That's a very common paradigm. So documentation RAG. There's also related to that is like RAG for code generation. So it's like retrieval and give me working code examples. That's like the blog I just shared. That's another very popular use case for RAG. There is RAG for, the most I hear is like RAG over technical documentation is like incredibly common, which can be textbooks, tech manuals, platform documentation, and like RAG for code gen is another big one within the RAG family that is very popular. I'm not sure that totally answered the question. Was it like, what are the different flavors of RAG?
Yeah,
or
I think that makes sense.
Yeah.
Yeah, just looking at the question again, they basically say they only use RAG for question answering. And I know that, for example, LangChain has a bunch of different chains for things like question answering, summarization. And I think that to echo what you said, any place where you want to augment an LLM's base knowledge with some specific context that is not, that you don't think is currently there, or context that you want it to pay more attention to, that's where RAG can be applicable. I'm curious, do you see that applying to things like agents and stuff like that, where you do want to augment your agents' capabilities?
Yeah, actually, there's a bunch of different points here. And actually, I see one point in the thread. So maybe there's one question here on RAG over fine-tuning, because someone mentioned Bluebird GPT. I think so. That's an interesting sub-thread on this topic. So actually, the Glean thing I shared covers this pretty well. There's a lot of reasons to use RAG over fine-tuning. One being that fine-tuning is not actually great for fact recall. This has been shown a lot. AnyScale is a good blog on this. Fine-tuning is better for form, not facts. If you fine-tune a model for RAG, you have to continually update it as the knowledge base changes. The Glean post gets into this. It's much harder to do authentication if you're just using an LLM directly versus retrieval stage you can like do filtering on. So I think RAG over fine-tuning is like a much preferred paradigm. So that's maybe point one. Point two is an interesting one related is you can fine-tune these domain-specific models. Yeah, fine-tuning costs a lot. So I think there's like a big question of cost there. And it's also more technical. So I think there's a lot of reasons to think about RAG versus like fine-tuning a model, even though I do agree that you can get these kind of domain-specific models like Bloomberg GPT that seem to do really well. I still wonder if they built a really optimized RAG system, it would probably be cheaper, easier to maintain, easier to authenticate, more practical for a production use case. So I think there's a lot of good reasons for RAG in production versus fine-tuning. So for agents, and actually I think about this self-RAG stuff is You can think about it as like agentic RAG. There's one interesting idea related to this that I didn't talk about. Let me find it. Corrective RAG. Where is? Yeah. So I have a video on this. I did a cookbook with Mistral. So here's the thing. The problem with RAG is it can be brittle, right? So if your retriever doesn't have information, and this gets into the agentic point, if your retriever doesn't have, so okay, you ask a question, your retriever does not contain that information. What happens? Usually, it'll still do similarity search, it'll return some documents, they won't be relevant. You'll generate some answer that's totally irrelevant to the user's question. That's a bad outcome. So one interesting paper recently is called Corrective RAG, which I actually implemented. Let me try to find it here. Yeah, building self-corrective coding assisting. Yeah, this one. So check this out. This is a video I did on it. So here's the flow. Basically, it's like it's a line graph flow similar to shown here. But if you do the grading of the documents, if they're not relevant, you kick out and do a web search and return the results from web search. So that's a really nice approach. I really like that. It's really simple and elegant. I'll share the notebook as well here. It's linked down here. This is like our most popular video of all time, actually, for LangChain. It's on this corrective RAG idea. You can see it here, where basically you do retrieval, you do grading. If they're not relevant, you do a web search to augment your results, and then you basically perform answer generation based on web search. So that is all to say, yeah, there's the video. I think RAG is probably better to think about than fine tuning. I think RAG can absolutely be brittle, like the agentic point, like in cases where you're asking a question outside the context of your index. And for those cases, I think using reasoning tricks, for example, this corrective RAG idea, where you kick out and do a web search, is like a nice way to augment a RAG system with like agentic reasoning and like a fallback to do just web search for retrieval of relevant documents. And I actually show this works really well. I use an example of, whatever, just you can watch the video. But basically, I index like one blog post, I ask a question outside the blog post, and it can kick off a web search, answer the question using the web results. And that's a long answer to say, I like RAG over fine tuning, but I like agentic RAG to have more flexibility based upon the input question to things that are outside of your index.
That was a super comprehensive answer. Let's go into Cameron's question, who asked, what public benchmarks are the best gauge for a model's RAG performance?
That's a really good question. I'm still a little bit unsure on this, to be honest with you. So here's what's interesting to look at. What I look at is, so for example, the CRAG paper did a bunch of evaluations. So here it is. They use this thing called PubQA. I'm nearly sure PubQA. Yeah, let me try to find. They used PubQA, ArcChallenge, and Biography. Oh, sorry, it's PopQ, or maybe it's, yeah. Basically, I would look at some of the latest RAG papers to see what the public benchmarks that people are using who are doing like state of the art new work is. Here's the thing though, I don't know how easy these benchmarks really are for you individually to actually run. They're probably heavyweight, there are lots of questions, there's probably as much as setup. I always build my own little domain specific benchmark. I run that in Langsmith personally. I shared some documentation previously on how to do that using Langsmith evaluation. That's how I do it. I don't really look at my RAG system on just like a random public benchmark. That's more for academic papers. I build my own little benchmark. I test it internally on my little challenge. That's how I think about it. Yeah.
Fantastic. Matthew asked, Opus seems to be able to understand needle in haystacks. Have you thought at all about what a good next level needle in a haystack might look like? Basically, questions about the needle in a haystack.
Yeah. I should note, I have not yet seen a full needle in a haystack analysis on Opus in the style I show here. So I started, I think Greg might finish it. So I think the current needle in a haystack assessments are too easy in general. I think all the reports that the model providers show are artificially easy, and I have some questions about them. In fact, I'll find the tweet. Someone just tweeted about this morning saying, Haystack's too easy because the question is too absurdly different. So I think multi-needle like I show here, or a more challenging benchmark is important first and foremost. Okay, to make it harder, I think one, more needles. So that's what I show here. Two, reasoning over the needles. Okay, yeah. So that's what I linked. I think 𝗏𝗏𝗃 essays are not pizza toppings. Let me see the first. Oh, okay, that's right. Because Claude 3 Opus, they did pizza toppings in their needle and haystack test, and this person is maybe saying, yeah, it's true that. Okay, yes, it is true that pizza toppings are not related to 𝗏𝗏𝗃 essays. Even still, LLMs can't find them. But I think, at least in the multi-needle case, like I show here, as the context grows. So I think multi-needle is good. I think reasoning over the needles is good. And I think there is a recent tweet, I'll find it when on the next question, talking about the needle should be more subtle changes to facts rather than something completely out of place. So I think that's reasonable as well. So those are three things: many needles, more subtle changes to the facts, and reasoning over the needles are three ways to make this harder. Let me find, while I'm at it too, the yeah. You can ask the next question. I'll just
while you're looking that up.
If this shows up, yeah. I literally just saw it this morning. It's always, Twitter search is never the best. Too easy. Yeah, you can go ahead and ask the next one. Yeah.
Cool. Yeah. Question from. Okay, this is a question related to the slides. Maybe this is about the needle in a haystack graph that you were showing. Ralph Step asks, any thoughts on why between 6 and 7 needles on the y-axis seem to cause a constant unrelated to the x values? So maybe just go back to that graph.
Yeah, exactly. This is a consistent result that we saw, which is pretty interesting. So around that 6 needles, so around the halfway point through the document, the ability to retrieve drops off a lot. This is that lost at the beginning effect that I mentioned. And it is not fully understood why this happens, but the best idea is from a paper that was linked to me on Twitter by one of the OpenAI guys, who said it's probably recency bias in LLMs. So what's happening is all the red is towards the beginning of the document. The LLM can't remember facts towards the beginning of the document because it's trained on an objective that biases for recent tokens. And that's kind of the best explanation I've seen for this effect. There's a lot of ways to address it. I'm sure it'll be fixed soon. But I do think, I think this is a limitation today. Cool. I'm also going to try to find that Twitter thing.
There's a question from Brian Swanee, who asks, what do you think about RAG combined with few shots training to introduce a sort of logic to retrieve better? Would it increase the performance of the model?
Yeah, interesting. There's been some works combining RAG with LLMs. Retro comes up as one example. Here's my kind of thing. Basically, for any individual user company, you really want to avoid the training game as much as you can. It just is complicated. It's costly. Fine-tuning maybe is acceptable, but again, I find it's not that great for RAG. It is entirely possible that you can increase RAG performance using some bespoke scheme that incorporates retrieval with the LLM itself. The problem is it's not tractable for like individuals to actually implement. So I would say, I'm sure, for example, that the state-of-the-art providers, Anthropic, OpenAI, are working on ways to like better incorporate RAG with the model in some way. Like in the future, maybe what you do is you bind your index, like it's like function calling. You bind the index to your model or something, and it like just uses it directly. I could see something like that, but yeah, I think it's not really practical for anyone to be. I would not, for example, try to look at retro necessarily and try to implement that like myself on my vector store. I think wait for the state-of-the-art models to better incorporate retrieval and probably through like a function calling type mechanism where you take your vector store and bind it to the LLM. And by the way, here's the thing, I'll share this out. This is the multi-needle thing I saw. Attention is not equal. Oh shit, this is not as good as there was some other thing saying that the way they did this analysis was that they more subtly modified the question to show that multi-needle is indeed harder. Yeah, you can look at their blog. It's fine. Yeah, I'll just send this out. This tweet isn't quite as good as the one I saw, but that's fine. But anyway, we can see a lot more red there. Yeah, have a look.
Awesome. Louise says, do you have any thoughts about retrieval-aware fine-tuning?
Yeah, again, it's related to that point of incorporating retrieval and fine-tuning. I think it's definitely interesting. I'm wary about, I think fine-tuning is interesting to consider, but it's probably, I would try everything with RAG first before I get into that game. It's costly, it's complicated. You need to redo it every time your index changes. So it's not something that like I've dug into very much because I haven't seen a huge demand for it from like the folks that like LangChain works with, for example. But I think it's an interesting trend to watch. My bet, like I said before, is I bet what's going to happen is one of these model releases, one of these providers are going to find a better way to bind your vector store directly to the LLM, in which case, like you don't actually need to provide a RAG prompt. It has some optimized way to access the vector store. I could see something like that kind of more likely happening. But yeah, it's an interesting trend. I should look more into it. Yeah, I'm actually just trying to find this other tweet, and it's annoying. You can never find it when you want it. Yeah, maybe it's from this guy, Thomas. Yeah, okay, here's the tweet from before that I was trying to find. Needle and haystack are flawed. The sentence is too easy. The 𝗥𝗲𝗀𝗃 can anticipate it. Make the sentence more subtle. All right, that's what I was looking for after all this. All right, here it is.
Awesome.
Cool.
Yeah, that's something that you mentioned, like in your 3 kind of recommendations.
Yeah.
So
yeah, exactly. I was trying to find that citation, but yeah.
Good to have that example. Okay.
Yeah.
We're 1 minute over time. That can be the last question
Cool.
since the other ones, we touched on them in some way. Just want to give a huge thank you to you, Lance, for giving this fantastic presentation. I also want to give a thank you to everyone that attended live, everyone that asked such great questions. Thanks everyone for joining us. I want to leave you all with a final plug. If you want to get 90 days free of Timescale, go to this URL. We'll also share in a follow-up email, and just have a wonderful rest of your day. And you can look forward to receiving the recording and all the slides and links. Some of the links, I'll try and collate some of the links and send it to folks in a follow-up email. So thank you, everyone, and have a fantastic day.
Cool. Yep. Thanks a lot. All right.